Hello, Rashmi.
Hello, Miguel.
How are you? We
Some
had
technical glitches
yeah,
today.
some issues. Yeah,
Yeah, this is like always. Sometimes OBS is crashed, sometimes LinkedIn is not working, but it's
yeah,
great. Now we are live.
yeah, good.
I'm good. Thanks. How are you?
I'm fine, fine. We got snow again here in Sweden this tonight.
Oh,
Already,
wow.
it started yesterday. We thought the spring
Okay.
was coming already, but
Okay.
no, seems like we will have a winter for a while.
Oh, yeah.
But
We are
it's
having
beautiful.
sun here, so we're enjoying. That's good.
It's really beautiful, but I really looking for the spring.
That's great. We are having
So
some sunny days last week, but now it's also getting cold.
yeah,
But yeah, that's how it is.
yeah. So today is about URSim on Docker.
Yeah.
Hmm.
Yeah.
So let's say we have been playing with universal robots for a while using URSim, using
Yeah.
the virtual machine. I think you can get
Right.
from
Yeah.
universal robots. Even with
Right.
RobotDK, controlling your robot is something that we do quite often, and so on. And
Okay.
both ways of working are kind of documented in the academy. So we have tutorials to set up
Yes.
both connections.
Yes.
But I think you and Ragnar have been playing around with this Docker containerized URSim
Right.
version. So tell me what's this about?
So we lately realized that URSim is offering Dockerized version, which means you can download the Docker file from the Docker Hub, and then you can run URSim irrelevant of which operating system you have. You can do it on Linux or Windows or
Hmm.
Mac. So what we have done, we have made a small system where we have a UR3 robot, and we are controlling that using URSim running on the Dockers. So I'm using Windows platform.
Yeah,
And I have a small code assist logic to show some pick and place application.
cool. For the ones that do not or are not familiar with Docker, uh, that can any computer use it? I think there is some limitations with Windows. You need to have Windows Pro to be able to use
This,
Docker, or
this I'm not sure
uh,
because I don't think this is a limitation. But
uh,
why do you think it's a pro?
it's because of the Windows subsystem for Linux thing. I think you
Ah,
can,
okay.
yeah. If I'm not wrong, maybe I'm wrong. So if someone in the audience
I'm
can
not
correct me,
sure about that. Okay.
you can write in the comments. But at least at least
Okay.
in order to run Linux in a Windows operating system, you need to have
Okay.
VSL, and then for that, I think you need to be able to virtualize some stuff and so on,
Oh,
and then you need the Pro version. So regular uh,
okay.
home version, I think previously at least they didn't support, and if I'm not
Okay.
wrong, Docker needs exactly the same technology. So it,
Okay.
as long as I know, it's the same requirement. We can,
Because I just checked my Windows is Windows 11 Home.
but
It's
then
not Pro.
maybe it's not a problem anymore, or
Yeah, I think it's not a problem
maybe
anymore.
maybe it's just for Windows subsystem for Linux.
What I know that Windows Pro is supporting this virtual machines
Yeah, 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 yeah.
by default. That was a requirement, so I can't
Okay.
do that in home. It's
Ah,
Hyper-V machines. Yeah, that's for
okay.
Pro. That's
But
what I know.
how were you running the URSim then? Were you running it with not a Hyper-V, but
So no,
okay,
just with the Docker. So I install Dockers on a machine. So I have a Docker server running on, and then I just pull the container from the Docker Hub,
okay,
or pull the image, and then I run a container.
okay. And the previous
Yeah,
version, the previous way of working using URSim, the virtual machine, that require having some kind
yeah.
of virtual machine software, right?
So that was with VirtualBox I was using
Ah,
when I
VirtualBox. Okay, yeah,
load the Linux image on that where the URSim was working before. And
okay,
that way is also working good, but
yeah,
it's just more complicated to
yeah,
install several softwares and then run your
yeah,
image. So I find Docker very easy to use, and you can easily save your progress, save your images, and
yeah.
share it with your others. It makes works very easy.
Yeah, actually, we have as a in our to-do list a plan of Dockerizing uh, both the Simumatik gateway and the workspace and the launcher, everything.
Ah, okay.
So
Okay.
it will be easier for the users to run our platform in any locally in any computer. So that's
That
something
would
that
be
maybe
great.
the day we fix it, maybe we can have a webinar about that, how to run it,
Yeah,
and so on. But
100%.
the idea today, you're gonna show what you did, uh,
Yeah,
have a walkthrough, and then
yeah,
basically you are gonna guide me to be able to do exactly what you did. Not all the way, but
right.
at least if
True.
setting up URSim Docker container
Yeah,
and doing some basic stuff so I can run the robot
right.
and move it and things like that. Okay.
So yeah, this is for the users who have never used Docker before. So we're going to do step by step.
Yeah.
I'm going to teach you or tell you how to do that. So
Mhm.
first, I will show you the complete setup that I created.
Mhm.
We're going to talk about that, and then we'll switch to step by step approach to do that.
Cool. Okay, but I think we
All right.
can go to full screen and show your screen.
Yeah, you can
Let
show
me
my
see.
screen, and I
Yeah.
can show what is going on. So a lot of things are going on my screen.
Yeah.
So you can see on the left side, we have a Simumatik system with UR3 robot with
Mhm.
some conveyors and some products coming in.
Cool.
And let me just go here first, just to show audience we have several models of universal robot in our
Yeah.
library, and you can use any model that you like,
Mhm.
and you can connect that with on the right side you can see this is my VNC viewer of
Mhm.
my URSim,
Mhm.
and you can control this robot by programming it here.
Yeah.
But in our example, I'm using UR3. Yeah.
Okay. Which model? Which is the biggest one? Is it the 20 or 16?
It's the 20.
Oh. Okay.
This is the UR20.
Oh.
And then it's UR30 because of higher payload, heavy payload. So it's
Okay.
UR30.
Okay. Yeah.
That's
And those
I
are
think
the
this one is UR3,
three.
UR5, UR10. I can show you. Let me see if I open the panels. If I select this one, this is UR3E. You
Uh-huh.
can see on the
Yeah.
right,
The
top right,
yeah,
this is UR5E, UR10E,
16.
UR16E.
Okay. Yeah.
This one is 16, and this one is 20, and this one is 30.
So the
So all
16 and
different.
the 30 are shorter, have shorter range, but
Yeah,
bigger payload. Payload. Yeah.
bigger payload. Yeah,
Mhm.
this is how
Cool.
they categorize. Here, what we are using is UR3. Let me just reset my camera here. And it's a very simple system. We have one robot picking the object from, we can say that entry conveyor and
Uh-huh.
putting on the exit conveyor. And here we have two sensors, which are going to tell us the color of the object, if
Mhm.
it's green or if it's yellow. And based on that, it will just
Yeah.
sort it on the other conveyor.
Quite cool.
So
Yeah.
system is actually
Simple sorting system. Yeah.
simple sorting. I mean, you can sort based on weight, based on type, based on material.
Mhm.
So I just use based on the color.
Yeah.
So we have the sensor, which is telling me the collision data, and based on that, I'm sorting it on the
Mhm.
conveyor. So this type of exercises we already have in the academy, sorting and understanding how to work with sensors and how to make a PLC program. These
Mhm.
things we will not discuss in detail,
No.
because here, if you notice, if I start my system, we have inside this panel a PLC
Mhm.
with digital input card, digital output cards. And this PLC is communicating with codices. So here is my codices program. So we are connecting these together by OPC UA.
Huh.
And you can use codices. You can download it for free. You don't have to get any license, and just quickly connect.
Cool.
And then, well, nothing much in the mechanical system. Here you can see on the bottom, we have a robot controller. That's very important. This
Yeah.
black box. It has two cards, digital inputs and digital outputs. So what is exactly happening when we are, which I'm going to show you later, when we are running the robot? This is connected to my URSim.
Mhm.
Let me just split the screen again. And this URSim is communicating the access value with the Simumatic, and also the IOs, the
Yeah.
digital inputs and outputs. So if you see on the top here, I have IO. Let me just make it bigger.
I'm gonna hide myself again, so I'm not in the
Oh, okay.
middle. Yeah.
So here you can see the installation. We have IO setup. And here on the right side, you can see I have defined some
Yeah.
Boolean signals. Robot picked, robot placed one, robot placed two, cycle complete. So these four signals are going from my URSim to Simumatic.
Yeah. Those are global variables, right? And
global variables.
you map some of
Yeah,
them to the input and output cards. Yeah.
yeah. And here on the left side, you can see two Boolean values, pick and place one, pick and place two. This is coming from
Mm-hmm.
PLC
Yeah.
to Simumatic, or basically Simumatic to URSim.
Yeah. I guess we will
So,
go through why is the 64 and 65
yeah, yeah,
and
yeah.
not the other ones later. You probably will
Yeah,
explain
other one
that. Yeah.
later.
Yeah.
So let's just run the system and see what's happening. So here I have some buttons to start the system. So we have first the box coming,
Mm-hmm.
and there are one diffuse sensor and one color sensor. So based on what type of object it is, the robot is going to pick it up and place it on this conveyor. So green one are
Mm-hmm.
programmed to go on this conveyor. And once the object is at the exit, it will be removed and next object will come.
Yeah.
And this is yellow and this is coming here. So this kind of simple programming is done on codices.
Yeah.
What should happen when the sensor is on, off? Yeah.
You know what? We had a question in the academy regarding the color sensors the other day,
Mhm.
and it was one guy asking how that sensor works because
Okay.
I think we had some tutorials where we have these boxes that can be
Yeah.
that the sensor can detect the color, but he was using other
Yeah.
products, and he was telling
Okay.
I don't get the color of those products, and I answered this user that what we actually are using is some data we store in the
Yeah.
product, and this is what we read and we get the color from. So actually these sensors are not getting the pixel color, they are getting data
Yeah. Yeah. Yeah.
inside the
Exactly.
product. And
Yes, the data.
maybe we can show it now when we are talking about this,
Yeah.
because I think
I
it's
can
quite
show.
interesting.
Yeah.
And this guy understood it and basically took these new products and add the data he
Okay.
needed, and it fixed it.
Yeah.
So then he
That's
could do the
great.
sorting. Yeah. But you
Yeah.
can show.
So
Yeah.
for example, this is the product 3 you can see on my screen. And if I go inside this product, you can see in the asset, this is just a thumbnail. Let's go to the editor and let me maximize it. If we go into the collision data surface, here you can see collision tag. It's RFID,
Hmm.
solid and conductive. So this RFID is basically the reason behind what
Yeah.
we are reading.
Hmm.
So in this RFID, we have collision data green. So this we type as a text,
Yeah.
right? Like
And
you said, we are not reading the pixel color. We are reading the text.
yeah, this is because there are two collision tags. I think it's RFID and
Yeah,
barcode. There is another one. I think you can
yeah.
search for
There's
that.
another one, barcode.
Yeah.
There you can see barcode.
Those two, when you add them to a collision surface, they allow
Yeah,
you to use the collision data, and
right.
what you can add to that collision data is a string, and it can be very long,
Yeah,
and the format is whatever you want. You can use
yeah,
JSON, you can use just pure string. But
yeah. That's true.
that's the key thing. Basically, we are telling, okay, we want to have some rich collision data in this
Hmm.
surface. You just do the trick adding the RFID tag to the collision tags,
Yeah,
and then you can write whatever you want in the collision data.
yeah. And we have to know what do we write here because this is what the sensor is going to read
Yeah.
in the end. So when I go out, and now if you see, this is the sensor here. Let me see, the sensor is SC01. And if I go inside,
Mm.
I just show you the editor. And here we are just comparing what is the collision data that we get
Uh-huh. When
from the
you
sensor.
yeah.
Yeah. And we might have some
I think it's the color to detect is what you
color to detect.
that,
Okay, this is the variable that we
yeah,
have.
yeah,
So if I show you again here, I have mentioned color to detect is green.
yeah.
So this you can write here which color you want to detect.
Mm,
So I did not hard code the sensor. You can write here green, red, blue. So whatever string that you write here, it will
mm,
compare it with the string inside this
mm.
product. And based on that, we will get a signal here.
Yeah, and that's just an example. I mean, you could do something more advanced. If you standardize
Yeah, yeah,
the colors, you could actually write the RGBA values
yeah.
inside the
You can
collision
write here.
data and then do more magic stuff. I mean, this is the
That's
very
true.
basic way.
Yeah,
So yeah, but I think it's interesting because this system is about sorting and using this
yeah,
color sensor, I think it was worth to mention because we had the question
Yeah.
also recently in the academy. So,
Yeah.
and again, there is a course in the academy describing all this
Yeah.
stuff. So anyone interested, you
Yeah.
can just go there and take a look. Yeah.
That's right.
So cool.
So
Yeah, I think it's pretty clear. So you have the PLC, the robot, using the Dockerized version of URSim. They are talking to each other through the inputs and outputs, I guess. So some
yeah.
outputs from the PLC are connected to inputs in the robot, and this is the
Yeah.
way you tell to pick and so on.
Yeah. So this robot controller over here and this iOS are talking to PLC controller and this iOS.
Yeah.
So that's how they are linked in the hardware. And important thing I want to mention here when you're running this Docker. So let me just show one window. This is my Docker desktop. And there you can see this is my container name, and that's my image file. And these are the ports, which are very important because we have to map the ports. Because when you're running a Docker in a container, this is isolated from my Windows environment unless I expose the ports.
Yeah.
So I have exposed these ports, 30,004. I just use the same number and there's 3 ports. So I can tell you what are these 3 ports. What does it mean? I've mentioned in the document. So the first port, 5900, this one, 5900, is I'm using for VNC access.
This is the
So I'm
user
using this
interface.
VNC.
Yeah.
Yeah. So I'm using VNC viewer. If you don't have this VNC viewer or a software, you can also visualize this on a web page.
Yeah. And this is
And
what
for
I will
that,
do, right? Later.
this is what you can do. And for that, the port is 6080.
Okay.
So this is for the web access. This is for the VNC viewer access. And this is for communicating the IO signals and the access value.
That's the API.
So this port, yeah, that's the API. So this port is what we use here. If I open up my robot controller, there you can see on the right side, I'm using this port 30,004.
Okay.
So that's how these ports are exposed. And that's how you can, if you don't expose these ports, your connection will not work. So you have to do this. And I will tell you when you are running step by step how to expose these ports.
Okay, so 2 for basically interacting with the Docker container and URSim inside, and another to allow Simumatik, the gateway, to communicate with URSim and gather data.
Yeah.
Okay, cool.
And here we are using, if you see, driver type is URDrive for this communication.
Good.
And the rest, I just connected the access of my robot controller. If you notice here, these are all the access value with the robot UR3 robot. So this is manually we have to connect. I mean, we can make this system public as well if somebody wants to test quickly.
Yeah, I think it's a
just
quite.
System right away.
I think after the webinar you can do it public, and then you call it sorting using UR5. So probably you call it probably you call it something similar. But we can can write the comments in the later in the YouTube for the final name of this
and here
system.
Here we have also mentioned a Google Drive link if somebody wants to read what I'm doing here, like this program, because I have saved an image and I uploaded the Google Drive, so you can quickly use my program. You don't have to start from scratch.
Yeah.
This I can also do for someone who want to quickly jump.
Okay, yeah, and this brings us to the last thing. There is a URSim Docker image which is what I will start playing with right now.
Yeah.
But that's completely empty. So this is kind of empty controller. So what you have done is clone that, I guess, start adding code, doing some setup and so on, and finally that image includes your code and everything. While what I'm gonna do now is just grab the image from directly from Universal Robot, the Docker Hub, and start playing with that step by step. So we get at least something. At least I can run jog the robot, maybe send and receive some signals from Simumatik. We will happy. We will be happy with that.
We will see.
Okay.
Okay,
Yeah, I
if you
think
like,
it's
we can then switch to your screen
yeah,
and you
I
can
think it
begin.
was clear. So
Okay.
maybe first thing, because I have access to your system, so I'm
Yeah, you
gonna
can just load
I'm
my
gonna
system.
load it, and then I have Docker here. So let's start. I'm gonna start this or load this
Okay.
system. It's the same system you had
Yeah.
with all the robots, and so this is because you created it in the same organization I'm accessing now.
Yeah.
So
Yeah.
we will make it public. Okay, so I think yesterday what we did, if I'm not wrong, we searched here for universal robots, right?
Yeah. Just search universal robot without spaces, and
Yeah,
then you will find most probably the first image.
yeah, and I think
Yeah.
it was this one. So actually,
E series latest or E
yeah,
series?
this is the latest one. Yeah.
Oh, that's the latest one. Okay,
So
that's good.
actually now it says run, but yesterday just we had this quick meeting to
Yeah.
prepare the webinar in order to not to wait now for downloading this 2.14
Yeah.
gigabytes. I already downloaded, so now I can
Okay.
run the container, the Docker container directly, but it is here. Okay, so this is
Okay.
the container that our audience needs to download. And I can find it now in images.
Yeah.
So
So you have this image. Okay, great.
now I guess I could run it here, but
You
this
can
is the
run it
tricky
here.
thing.
Then
But that the tricky thing with
but
the ports. That's the
it will
important.
ask you for the port as well. I think in
Okay.
Docker Desktop, it's now a bit smarter. You can try.
Okay, we can
Click
try.
on run, and then it will ask you for the ports, optional settings. Yeah, there
Aha,
now you
cool.
can put
Okay, are they
host port. Uh, I can tell you one is 5900.
okay?
You can just put
5900. Yeah. Is it TCP?
and
Are all
it
TCP? Yeah.
yeah,
Oh.
yeah. And I'm wondering where is the container port in this UI? Because there should be container port and host port. Can you
Uh,
write something there? If you put column 5900, would it work?
no, it's okay. Wait. This is the host port, and this is the
Oh, okay, there
these
I
are the
see.
internal port. Okay, so I need to
Okay,
map.
there you see.
Yeah, I
Yeah,
mapped 1500.
right.
Which one?
Here,
This one,
6080. Mhm. The
6080,
same, 6080
and
and
this one, right?
3004, right.
Okay, so the three you were mentioning, I guess I'm mapping my 30,004 to the 30,004 in the Docker image,
Right.
and the same here. Yeah,
And one more thing, you have to define the robot model. I'm wondering if you can define it here.
I have some environmental variables, volume, container.
You can put in the environment variable robot underscore model in caps lock. Maybe this will be
The
it
big
in
okay,
capital
robot model. Okay,
underscore, and the value will be UR3.
you are three. Okay,
Yeah, this should work. And I think it will give the container name by default. So you can
I
try to
can
run
I
and
can
see.
add a name here.
Oh, you can add a name here. Okay, that's
Okay,
an
I
important thing.
can call it URSim Mikkel. Okay.
Yeah,
So basically, as you were mentioning, we can run it a bit with this wizard. We could say a bit
yeah,
smarter wizard with some optional settings. URSim Mikkel. This is
yeah.
the name. We map some
Hmm.
ports in my computer or
Right,
in the host
right.
to the Docker
Yeah,
instance.
yeah.
The 30,004, 5900, and 6080,
Hmm.
and then
Hmm.
this is because it kind of makes some configurations in your sim
Yeah,
if you
yeah.
define the robot model. So let's try
Right.
it. Um,
We have to define robot model because it automatically starts the interface with the robot model.
mhm.
So you can't change it inside once you're inside. You have to start the container again.
Okay,
So
so
let's see.
here, yeah,
Looks
here we
like
have
good.
something going on. In order
Okay.
to see if your sim started properly, I guess we need to open an interface to the Docker container.
Yeah, you can go to the, you can also start the browser and
Yeah.
open localhost 6080.
Okay.
Then you will find a
Ah,
list of
cool.
files, and
Yes.
then you can start VNC HTML on
Yeah.
the second last file.
So this means that now we are talking to the Docker instance.
Yeah,
Hmm?
right.
And this is this
This,
is what we tested yesterday. Basically,
yeah,
I
yeah.
opened this and
Click to
Anslu. This
connect.
is connect in Swedish.
Yeah,
Yeah,
the Swedish. Okay,
yeah,
that's
cool.
right.
So I'm
There we
inside.
go.
Yeah.
Yes, you're inside. Now you
Oh.
can maximize it.
Mm-hmm.
So just in the beginning, it will ask you to confirm the safety configuration. So because we're in simulation, we don't have to worry about that. You
Yeah.
can
Okay. I
confirm it.
just click here. Yeah.
Yeah. And then you can go on the left side, power off. You can click on that button.
Yeah.
Then you can turn on the power.
Okay. So we are starting the controller. Cool.
Yes. And one thing, it is asking for payload. If you want, you can also give some value in kilobyte, but it's for simulation, it's fine. But you can still give maybe 1 kg
Okay.
or 500 grams, however you like.
We leave it like this. Okay. Cool.
And you can click on start again.
Start.
There you go. That's it.
Okay.
So now robot is up and running.
It's quite happy. Yeah. Normal.
Yeah.
Yeah. Great.
Now you can exit on the button on the bottom. There's an exit
Yeah.
button. That's it.
Okay.
Now you can say program the robot because we have no program
Okay.
inside.
Yeah. And here we cannot the instructions and so on. Maybe what we could test is just jog it. Now we have
Yeah.
URSim up and running.
Mhm.
I could try to connect. Let's see where the model is
Simumatik.
here. Yeah, Simumatic,
Mhm.
not the Docker. I open this one, and actually
Mhm.
I'm gonna split screen so we can have both,
Yeah.
as you had,
Yeah.
and I can start the gateway.
Yeah.
And now we can go through the settings again, just
Mhm.
so I understand what we are
Yeah.
doing. So
Yeah.
here we have the
The
robot
options
controller,
here.
and the
Right.
driver is your universal
Mhm.
robot driver, localhost. Yeah, it seems like
Mhm.
localhost port 30,004. We know that is mapped to
Right.
the Docker. So
Yeah.
basically, we don't need to know the IP address of the Docker instance. We are
Yeah.
just breaching
We are local.
this
Yeah.
port. So that should be okay.
Mhm.
Anything else we need to consider?
That's it. I
That's it.
think that's
That's
it.
it. Yeah. Okay, so maybe we can just click play and see what happens.
That's it.
It
Mhm.
should say running. Yeah, and actually the robot
Yeah.
moved.
It's
Okay,
running, and now you see the
cool.
robot takes a position.
This was really easy. Okay.
Yeah, it's very
So
easy, no?
yeah.
Just
And I guess now in move I can jog the robot, right? Yeah.
yeah, you can
Cool.
jog the robot. It's crazy.
Oh,
So you can imagine there is no limitation in this Docker version. There is no trial version. You can play as much you want. You can program the robot and
yeah.
start playing around with robot
Cool.
program.
Okay. Oh, that's easy. And
If
I
you
can.
want to make a tiny program, you can also do that if you like to just
Yeah,
show.
I was thinking that maybe you can show me how to teach a few
Okay.
positions. Yeah, just make a loop so we have the robot pup moving one from one side to another,
Yeah.
and then I would like
Yeah.
you to explain me how to map the inputs and outputs. And I'm wondering
Yeah.
why this number 64 and 65. Why not other numbers? Probably the
Mhm.
audience is also wondering that. So you can explain us why how we map and what are the options we have if we can map both
Mhm.
bits, integers, words, or what options does offer URSim. So maybe you can
Okay.
show me just how to teach a couple of positions and make a
Yeah.
loop. Hmm?
Let's do that. So in this case, you can go to
Program
excuse
or
me, program. Yeah,
Mhm.
program. And then you will take on the left side, we have an option of move.
Yeah.
Huh? You can click on move, and
Hmm.
now you can see there are two options, move J, and on the right side, you can change to move L. So it's like a
Huh?
joint movement and linear
Yeah.
movement. So
Yeah.
you could do joint movement, just for
Yeah.
example. And the waypoint one, if you click on waypoint one now on your
Huh?
program, you can click on set waypoint.
Okay.
So you can define now where you want to move. So now you can move your robot,
And this is
and
the
you can
actual
see, okay,
position, maybe, right? Or not?
this is the actual position.
Okay.
So if you
Yeah.
now you can define,
Let's take
if
that
this is
one.
okay, you can click
Yeah.
on OK.
Yeah.
Okay, you can
I
click on
think.
OK.
Uh, where's
And click on OK, this green button.
this one? Okay.
Yeah.
Okay. So
Now
now
you can,
waypoint one is the actual position. Okay.
right. Now you can do another move command.
Okay.
Click on the left.
Move. Okay.
Yeah. Now you have waypoint
Two. Ah, okay, and
This you can bring down.
this went
Yeah, because
up.
it just come on top. Yeah,
Okay,
there is a button on
uh,
arrows.
okay.
Arrows. Yeah, yeah, this.
No drag and drop. You need to use this.
Yeah, yeah.
Okay.
So you can
Okay.
go to waypoint 2, set
Set waypoint.
waypoint,
Okay,
and
and
now you
now
can give a different position.
I could just do something like this. Very easy.
Yeah.
So I guess I'm moving the robot somehow. Let's see.
Yes.
We do it like this. Uh,
You can also do on the arrows on the left
yeah,
side, a big arrow. So
yeah.
okay.
Maybe
Now
like
you.
this. It doesn't need to be very far, so we do
Yeah, yeah.
this.
You
Maybe
can click OK.
and click OK. So now we have two positions. Okay, cool.
And now you can run these two positions. You can run the robot program.
Okay, how do I do that?
It should
Here,
be, I think my photo is on top. My
play.
camera is on top. You can remove my camera.
Ah, okay, yeah, yeah.
You
Sorry,
can
sorry.
see.
Let's see. Yeah. So this
Yeah.
is this
Now
play
I can
button,
click on
right?
play. Right. You can say play from beginning.
Oh,
So it is asking you, your payload is set to 0 on the installation tab. I think we changed the payload. We can try that again.
okay.
You can click on this button. You can hold this button.
Okay.
So it will go back to the first position.
Okay, and
Now
play.
we can say play.
Oh,
Robot
no,
program.
cool.
Now
Exactly.
we can
This is
use
what I
this one.
wanted. Okay,
Yeah.
great. I'm gonna bring you
That's good.
back. So now we know where is the play button. So there is a play
Yeah.
button. Sorry, there is a play button, the reset,
Yeah.
the stop button, and I guess some reset kind of button. Okay.
Yeah.
So I wanted to have that, and I guess now I can reset the emulation in Simumatic,
Mhm.
but still the robot is running here.
Right. This is running.
Where can we see the robot?
You can see the robot in move, I think.
Here,
There.
installation,
One way
at
is
least
here.
here. So if I connect Simumatic anytime, it will catch up and follow it in real
Yeah.
time. Yeah, cool.
Right.
Okay, so I think like this is almost the same perspective. Yeah.
Yeah.
Okay, cool. Okay, so we are not giving a tutorial of URSim, but
We have one tutorial in the
yeah,
academy, so
yeah.
they can also check
So
and they can
I'm
watch it.
pretty interested in the input and outputs. How you did
Okay.
that? So you were here somewhere
So
here. Yeah.
we can switch the screen if you like, and I can show.
No. So you want to see which screen you want to see, the URSim or Simumatic?
This is, you can show my screen.
Okay.
I can show in my computer.
Okay.
It's
Cool.
much easier. So let's make it bigger if I can. This size is fine. So first I can show you in my robot controller, I have two cards, digital
Mm-hmm.
input and digital output.
Mm-hmm.
So if I click on this digital input card, here you can see on the right side, I have some variable declaration.
Yeah.
I can just input bit register 64 and
Okay.
65. So these are the two registers I'm reading.
Okay, but
I
those
can
are
mention
Boolean
more
ones.
as
Huh?
well.
Yeah, and
Those
those
are
are
those are
Boolean.
defined in the array. Yeah.
Yeah. So you are using this way we have instead of just having one variable for the entire for
Yeah.
all the bits in the card, you are mapping
Yeah.
a variable to port directly.
Yeah. And if you want to see where is this coming from,
Mm-hmm.
this you can see in the robot. If I go to installation, IO setup, and this is here 64, this one, and here
Okay.
65. So I'm taking these two. You can take any number. I just randomly choose because sometimes we are using this internally. So I choose 64 and 65. And
But
these two values are here.
but why you write input bit register 64 and not pick whatever you had in the name of
Okay.
the name of the variable? Where is it coming from? Yeah.
So this is mentioned here, rename to use in program. So this variable name we can only use in URSim,
Okay.
inside programming. So this variables, if you see pick and place 1 and 2,
Mm-hmm.
they are in my program.
Mm-hmm.
So I read if my pick and place 1 is
Yeah.
true, then I call a subroutine. If pick and place 2 is true, then I call another subroutine.
Okay.
So I can still use, I'm not sure if I can still use GP bool in in my program, but they asked me to rename it to use in the
Yeah,
program. So it's a step.
yeah. But the mapping between that and what we write in Simumatik, is there any convention why you need to write
This
input
is
bit?
mentioned in the user manual. I
Okay,
searched on the internet about how we can map it. So they have mentioned in their manual. I don't have the link right now to that,
okay.
but I can put it in the resource of the video lecture
This is
where I can
because
get this.
this is probably because the API we are using to gather data from
Yeah,
URSim is telling us that we need to use for the register input registers. We need to call the variables like that, and then we can do
yeah,
a write or read. Okay, so
yeah.
let me share my screen, and I'm going. I
Mhm.
want to show the user manual just to see if
Okay,
that is properly mentioned as well, because
okay.
we should have
Let's have a look.
here the universal. We haven't checked that, but I hope no, we don't have
This
that.
is the old one, huh? Yeah, I saw this naming convention in the Universal Sim documentation. Let
Yeah,
me check.
I would like to know where this convention is coming from.
Okay. Ragnar was showing me this link, and
Okay, maybe we can
let's see if we can
because I
find
think it's important that we share it here,
it. Yeah,
so everyone knows. Okay, if I want to read this register, I need to use this name. Maybe you have
yeah.
it. Do you have the link in your screen? Because maybe we can just show it.
I'm just checking if I
Okay.
can find out somewhere. But let's see.
Yeah, this looks familiar. Yeah, there you have it.
Yeah,
Yeah.
here we go. Here we
Mhm.
go. So these are the input bit register naming from 0 to
Yeah.
31, and then 32 to 63.
Mhm.
And there you can define for 64 to 127.
Yeah.
These are used for external RTDE clients.
Exactly, because what we are using is this RTDE API.
Okay,
What is
API.
is
Okay,
real-time data exchange protocol or
data
something like that.
exchange.
So
Okay,
this also explains why you started in the 64, because the previous
yeah.
ones are used for field buses and other stuff.
They're used for bus PLC,
Okay,
right?
so we cannot forget to add the link to this document in our
Yeah,
academy in the user manual.
I
So
will add that.
yeah,
Yeah, reference.
because this is perfectly explained now. So
Yeah,
yeah, somewhere here we need to add that. So basically, let me go to my version of the model. I
okay.
have here, I guess, the same configuration as you. Yeah. For the input,
Yeah,
bit register 64 and
your camera is
55.
on top, so your
Sorry,
camera
sorry.
is on top of
Yeah,
it.
sorry. I'm gonna move myself somewhere else.
You logged it. Okay, yeah,
Let's move somewhere else. Yeah. Yeah, so here we have the outputs 64,
hmm
65, and 66, and the inputs are 64, 65. Okay, cool.
yeah,
So basically, in order to get those signals, I need to uh, create them
yeah,
in URSim here.
yeah.
So where do I declare them?
It's an installation,
Okay,
and then IO setup.
cool.
There.
Okay, yeah. So actually now I'm getting them, but I'm
Mhm.
not mapping them anywhere, right?
Yeah, you're not using it
Yeah.
in the. Yeah,
Okay. So let me see which this is. Which are the registers? Which were the registers? Is this
it was bool in.
64 and this one maybe, or is this one?
It's GP underscore bool underscore in
Yeah,
64.
this one. Okay.
Yeah, this one.
So I'm gonna call this test in, and I
Mhm.
want the equivalent for the output, which I'm
This
reading.
one is GP underscore bool underscore out
Now
64.
I'm gonna call this test out.
Okay.
So basically now I just map or name differently the 64 and 60 input and 64
Yeah.
output, which actually are already being somehow sent to
Yeah.
to the robot.
So this
Could
is
I?
already connected.
Yeah.
Yeah.
So I want to do I want to mess around a little bit. So basically, what I want to do,
Mhm.
I want to connect this green button to the input
Mhm.
card. So I want to remove this
Okay.
and add
Yeah.
the button instead. So I want to see that
Okay.
when I press the button, I move the robot, for example. And then maybe when the
Okay.
robot has finished, I want to switch on a light or something like that. So we actually see that we do some
Okay. Maybe then take a
connection.
toggle button because
Yeah,
that stays on all the time.
this one.
That would be, I
Okay,
would say,
then we
yeah.
take this one. Okay, this is position
You
switch.
can connect
Yeah.
that to
So we take
digital
the
input
digital
of robot
input. Yeah.
file.
I'm gonna
Yeah.
remove this
Robot.
and this.
Mhm.
Yeah. So let's go to control and switch and the 14. Yeah. And
Yeah.
then I want to connect the outputs. I'm gonna remove the actual connections in the
Mhm.
robot. And I just
Okay.
want to remove, I want to switch on one of the inputs here. Let me see. Power supply, this one. I'm gonna connect it
Okay.
here.
The light.
Okay. The
Okay.
light, to the light.
Mhm. Mhm.
So this is light
Robot
beacon,
output.
light beacon
Mhm.
X1. So we go here
Okay.
to the robot, digital output card, and we take this one.
Yeah.
Okay. So
Yeah.
now, according to this configuration, this switch is gonna be connected to the first input in the robot. Let's check. It should be
Right.
here. Yeah, the switch, and now the output is
Mhm.
connected. The first output to the beacon. Okay. So
Correct.
if I play this, uh, I want to see what happens if I go to iOS.
I don't know if you can monitor it in iOS. Maybe not because it's
Yeah,
more external
yeah.
digitalized.
I wonder
But,
if
but you can make a logic with
yeah, that we can do
if
the
you
logic.
like, if else. Mhm.
Yeah, because here you see the
Just
closest
digital.
one, the first ones. Yeah, yeah.
Yeah.
Maybe here you can. Oh, maybe here you see them. No registers. No, this is a Modbus thing. Okay,
Modbus.
okay. Don't worry. Let's do one thing. Let's, instead of running this in a loop, we can do that. We wait until the
Mhm.
signal.
Yeah.
So maybe
So we
wait
can
at the
use wait.
wait and then
Mhm.
wait for
For digital's input, right? And completely in the end, you will find your
testing. Yeah.
testing.
And I
Mhm.
wait until it's high, right?
Yeah.
And then we move. And then at the end, I want
Yeah.
to set the output. So, oh, I want
Yeah.
to move this way. Yeah. Set
Yeah.
digital output. And then we go
Right.
down. Test out. And I want to have it high.
Yeah.
And again, I want to add another wait. So I want to wait until this is low now. So I just want one
Mhm.
cycle. So
Okay.
yeah. So I wait until I switch this key. Then I want the robot
Mhm.
to move from waypoint to waypoint 1, then to 2, then switch on
Then you
the
can also
light, and then wait until
Mhm.
I switch off. That
then you
makes
can also
sense.
turn off the light. You can also turn off the light, then you have a complete cycle.
Yeah.
So you
We could do at
in
the
the
end.
end you
Yeah.
can do set.
Set, and we can switch off the light.
Yeah.
Cool.
Okay.
Okay. Cool. Do I need to save somewhere or not, or is
Now you
automatically saved?
can save this. You can save on the top. You can see
Here,
save.
yeah, yeah.
Yeah.
Save.
So now you have to
Save.
give a name of the program.
Okay. We can do it just to test. Okay, cool. And you are above the play key,
So
but
that's the program.
I'm gonna click the play button. Okay, so let's
Okay.
we run that, and I run it from the
Mhm.
beginning. Again, it's telling me
Yeah.
that the
Yeah.
robot
You
should go.
press it
Let's
to
show
the main
this.
starting position. You can just click. Keep it flicked.
I'm really liking it.
Yeah.
Yeah. Okay. Cool.
You can do some
Let's see.
workshop for your school.
Let's see. I guess we need to restart this because we need to connect things properly. Let's see. Okay, so this is waiting here, and let's see if I
Mhm.
do like this, nothing happens. Why not?
Is the robot program running?
Uh,
Check the signal at the robot input if it's coming. Oh, you did not. think you work with the variables already in the inputs and output cards of robot.
Let me see.
Check what is there,
Let's see
because
what
it's
the
looking for
robot
the variables.
controller is saying. Variable found, blah, blah, blah. This is running. It seems to be happy on the input card. Uh, oh, oh, I don't have any signal here. Maybe it's
You
not.
don't have a signal.
Maybe we don't have power in this. I didn't check if you. No,
Check.
we
Oh,
don't have
oh,
we don't have the power supply connected. So it's. I understand why
I'm
we
wondering,
didn't get.
we
Yeah.
did not did we remove the power supply? I don't
Maybe
remember.
I did. Maybe I did it. Maybe I just clean
Okay.
it up. Okay. So let's see.
Okay.
I'm gonna check input card. Uh, Now, yeah, now we have it. Yeah,
Okay, good.
it's moving.
So now it's working and then it stopped. You can start again.
But did the robot move?
I didn't see because it was covered with your window.
Yeah. Oh, yeah, it's moving. Yeah. Okay.
Yeah, it didn't
It
move.
goes.
But
It's
yeah,
just
light
very
is also
quick.
on.
Yeah, and the light is on.
Yeah.
Okay. Okay. So we cannot did it. So I need to switch off. Now we start.
Mhm.
I activate the signal. The robot goes waypoint
Yeah.
1, waypoint 2, switches on the light.
Yeah.
Okay. And then I
Right.
can reset the
Right.
cycle. Cool. Okay,
Correct.
we just missed that we didn't have power or
Yeah.
the power supply connected to this switch, so we couldn't give a
Mhm.
real high value to this signal. So perfect. I'm super happy. I think I can play around with this cell now. But
Yeah. I
basically,
mean,
yeah, I know how to create targets and waypoints.
mhm,
Move G and Move L, and these are standard in robotics, so I'm
mhm.
quite kind of familiar. And now I understand, thanks to what you show, how I can map
Yeah.
signals. So basically, if I would like to add more signals to the robot, I need to come to the input card,
Mhm.
not the PLC, sorry, but in the robot.
Yeah.
Where is the
Is
robot?
in the robot on the below? On the below,
Here,
there's
yeah,
another robot.
yeah.
Yeah.
So here I will need to add more registers, 66,
Right.
65, 67, and so on, if I want more signal, and
Mhm.
then connect them to different sensors, buttons, or
Yeah.
whatever I would like. And the same for the
Right.
outputs. Yeah. And
Yeah.
then
That's
it's
right.
super easy to use them, actually. The only thing was that they are appearing at the end. Okay. So I had to scroll all the way down to find the ones that
Mhm.
I declare or map manually here
Mhm.
in the installation, but it was pretty straightforward. So
Yeah.
it looks like we have a
What is
lot of
also
inputs and outputs to use.
what is also interesting is, which I haven't tried yet, if you have two robots, you can run another Docker container, define different ports, and you
Yeah,
can have two robots programming simultaneously in one screen.
yeah, I
This is
guess.
also very interesting.
I wonder.
Any?
Yeah, maybe the only thing we will need to do is use different. The main problem
Protocol.
could be the interface, because now we are using localhost 6080.
Yeah. Yeah.
When we define the Docker container, maybe we had to map 6081 to
81.
the other
Yeah,
one,
yeah, sure.
to the other
Yeah,
Docker
yeah.
image, but
So
it
two
should
different
work. Yeah.
ports and it
Mm.
should work. Then you have two robots or three or four,
Yeah.
however your machine supports,
Mm.
and then you can do multiple programs. This is also interesting
Yeah.
to check and verify.
Yeah, as long as your computer managed to have several Docker images running at the same
Yeah.
time, or containers, I think is totally possible. Yeah, cool. And a fun thing is that I could connect this robot as well to the same
Yeah.
robot controller, or maybe
That's
this
true.
one. So I can take
Yeah.
this and control it, connect it to robot, and select the same axis as I have in
Yeah.
this one.
That's the fun part of simulation.
Yeah. So basically, what we are doing is that mechanically we are connecting two robots to the same
Yeah.
controller. Uh,
Yeah.
this probably cannot
Yeah.
be done in reality, but now if I click play, uh,
Yeah.
both both robots are gonna do the same. So
Going
let's see.
through. Yeah.
Yeah,
Interesting.
cool. Oh, but I'm really happy, and we just have 5 minutes left. So I think
Mhm.
we managed quite well. Uh,
Mhm.
thanks, Rashbir, because it was quite comprehensive. And if I manage to do it, probably the audience can do the same.
Yeah, I
It
understand.
was super straightforward. I'm not super familiar with URSim, but it seems quite
Okay.
easy to use.
Yeah, it's very good. I was
Mm,
using it in my last job. I was giving trainings on URSim. We had
mm,
robot programming for also for sorting mechanism.
mm,
So I've used it quite a lot.
mm. What
I'm quite
about
familiar with
if
it.
we want to send integers and so on? Did you try this?
This I
Mapping?
haven't tried, but you
Okay.
can try as well. But then it's difficult to compare the value inside the robot program,
Aha.
you know, because here you have Boolean variable, you can easily compare weight for
Okay.
this Boolean signal. Otherwise, you have to.
So if I create this variable, then and I go to
Mhm.
the robot, uh, maybe you can do. You can wait for analog input. Maybe this one, right?
No, no,
Ah
wait
no.
for then maybe a function on the
Ah,
bottom. And
okay.
here you can write inside. If you go, then you can type your variable name, or if you can find
Yeah,
here.
this one. Yeah,
Yeah,
is maybe
but I don't know
bigger.
how do you map it. Yeah, this you can do, but it's a bit more complicated than using Boolean.
Yeah. Interesting.
But for sure, you can do that as well.
Yeah, we should try. I guess if I map
Mhm.
this and I have another, I have an analog sensor. I map it to
Yeah,
this value. Probably
this
I
you can
could do
do.
something like that. Yeah. Hmm.
Yeah, with analogs you can do.
Yeah, or maybe even mapping the analog signals to the to variable, right? Directly, because we have floats, we have the booleans, and we
Mhm.
have here the analog ones.
These are, I think, are the physical analog IOs, which are in the robot
Yeah.
controller in
So
real.
we need to know which registers we are actually allowed to use because we were
Yeah,
not
yeah.
allowed to use up to the 64
Up
here.
to 64, yeah.
Yeah. So
So
for
you
the
can use
external,
after that.
we need also to check in the link that you mentioned before which are
Yeah,
the integer registers that are available
yeah.
for this protocol. Okay, cool. Do we have any question or nothing?
There is one question from Sinclair. He's saying, awesome, I would like to find out if I have to specify the robot payload and center of gravity in the installation menu of URSim VNC. So, like I said, because we are working on the simulation, you can mention the payload. If you don't
Ah,
mention, even then
mhm,
it will just warn you, and then you can still work on that.
yeah.
So, center of gravity as well, you can mention if you know the gripper, which gripper are you
Okay.
using, because it will affect the center of gravity as well.
This is
Because
the
here, if you
payload.
notice, we did not, yeah, we did not mention any gripper in the URSim. We are just having a gripper in uh, Simumatik.
Yeah. And this, I guess, running in simulation or using URSim, it probably doesn't make much difference to set
Yeah,
up the payload, right? Yeah. Is
yeah,
this is something maybe that in the real controller with the real robot it kind of
yeah.
compensates or whatever the center of gravity and so on in some movements, but
Mm.
now okay, hmm, cool. But
That's the question we have. But yeah, we are good on time today.
yeah.
Last time it was very short, but today we are good on time.
Okay, but it was really fun. Uh,
Yeah,
Probably we
it's
can
great.
use some of this webinar in the academy as well. We add this link to the user manual, and
Yeah, I will add this to the gateway course. This, I think, belongs very good to that
mhm,
course,
yeah,
how to interface yours and its environment.
good. But then
All right.
thanks a lot, and we just 1 minute left, so I think we can say bye to everyone. Thanks for
Yeah.
watching,
Thanks for
and
joining. And we will have the recording for sure. If you join later on, you can anyways watch it again.
yeah.
And stay tuned in our LinkedIn for more updates and more
Mhm.
webinar news.
And it is totally okay to ask questions or write comments in the YouTube
Yeah.
recordings for these webinars because we
Yeah.
put them in YouTube as well.
Yeah.
So we will try to answer them as soon as possible. Otherwise, they know about the community and the academy, so there is plenty of ways of contacting, reaching us. Yeah,
All right.
good. Okay, but then have a nice
Okay.
day, everyone. See you
Thank you.
next month.
See you
Thanks,
next month for the
Rajbir.
next webinar. New topic. All right.
Bye
Take care.
bye.
Bye bye.
Bye.